we are focusing on a little bit more theoretical and experimental probability. So we're going to bounce through and talk about some of these ideas, and then you'll go back and finish them up. But the big question is, what is probability? Can you think about how you would explain it to someone, what probability is?
The chances of something happening.
Okay, I'll take it. The chances
Small.
or the possibility of something happening. So the chance that something happens. Oh, that something happens. Probability will always be between what? We're thinking about numbers.
0, 1.
Always between 0 and 1. And you can also look at probability as a fraction or a decimal. Sometimes you're given the probability in sort of a percent form. All right, introduction, flipping a fair coin. It makes sense that every time we flip a fair coin, the probability of flipping tails is 1 out of 2 or 1/2, which we could also write as 0.5. All right, theoretical probability is in theory what should happen. It is the probability of your event, and it's the number of favorable outcomes over total outcomes. So for us, the favorable outcome was flipping a tail, and the total outcomes was 2 for heads or tails. So that's all. All right, so we are going to flip a coin 10 times. Would this be experimental or theoretical? If we flip it, it would be experimental. So let's do that. All right, so we had a little bit of struggle, but we flipped some coins, and the first flip didn't count because we had too many coins. But the second time, we had 8 heads and 2 tails, which is really off of the idea of having 0.5. So then we flipped some more coins, and now we had 4 and 6. So if we add these together, that would have given us 12 and 8. So if I would take the idea that the more coins I flip, the more times I flip a coin, the closer I'm going to get to that 0.5 probability of heads, 0.5 probability of tails. So the more coins we flip, the more accurate we will be. So if we look at this data on average, about how many times did the class flip heads out of 10 flips? Well, we're going to change it to out of 20. And it said that we flipped heads 12 out of 20. So what is that as a decimal? 12 out of 20?
Yeah. 3.5.
I was going to go with 12 divided by 20. Should be 0.6.
Yeah, 3.5.
Oh, I thought you said, okay. So 0.6, which is a little bit more than half. Now, if we would keep flipping our coins, we would get closer and closer to 0.5. All right. Experimental probability is based on experiment. So I'm going to leave these 2 questions for you guys to do. It doesn't specify, but I will tell you always, I'll take a reduced fraction or I will take a decimal. But you have to reduce your fraction. So you're going to come back and do these experimental probabilities. Now, if you flip it to the back, it's asking you some ideas about rolling a die. If it does not specify how many sides does my die have, it's going to be considered a standard 6-sided die. So anytime someone's talking about rolling a die and they don't specify, it's going to have those 6 sides, 1 through 6. Flipping a coin would be 2 outcomes. And then we're going to look at this. It says deal or no deal, which I wouldn't expect you to know, but that used to be an old TV show. It says the probability of getting 1 million is 1 out of 30. So what's the probability of not getting 1 million? Just think about it. There's 1 out of 30 ways to get 1 million. There's 29 out of 30 ways to not get 1 million. That's the idea of the complement. Okay, so make sure you're paying attention. When you're rolling a die, these are all 3 questions about rolling a die. This is questions about days of the week and a question about a spinner. And it says numbers 1 through 8. Just know that they are equal sizes, equal sections. Okay, now jump down here so you can answer those. Take a look at the sample space for the following problem. We have a bag and it contains 3 red chips. I'm going to write that down. 3 red. It contains 2 blue, 5 green. How many total chips are in the bag? Do we agree with his 10 chips? Okay, so if you're asked to find the probability For blue, it would be, well, there are 2 blue out of 10. Now, you're not going to leave me that answer. What would you write? 2 out of 10 is 1 out of 5. I will take that, or if you want to, 0.2. Now, let's look at this one real quick. It says probability of red or blue or green. Well, what's that mean? It says or. Remember?
Getting any of those colors.
Yeah, are those all the colors? So wouldn't it be 10 out of 10? You're going to get one of those colors, so it's a probability of 1, which means it will happen. Okay, so the probability of a certain event is, if something is certain it's going to happen, the probability is 1. If the probability of an event is impossible, if it's impossible to get, the probability is what? 0. Okay, last ideas together. If you look at a deck of cards, so you have your paper in front of you, and so I'm going to let you fill out this chart using your deck of cards. As in, how many reds are there? Well, just all together, there's 52 total cards. We do not include jokers. So when you're asked how many red cards there are 26. Half the cards are red. Okay. If you're asked for how many hearts there are, each suit, there's 13. Okay. Then it's going to ask you the probability of getting a queen or a 7. So if you can think about this, how many queens are in your deck of cards? It doesn't matter what color. There are 4 queens. And how many 7s are there? 4 7s. So there's 8 cards we can get out of 52. So the word or means I want a queen or a 7. So there's 8 options for me out of 52. And then you would reduce that. And what do you get if you reduce it? Should be 2/13 or the decimal. So pay attention that you are looking for things. Notice this says not red nor clubs. So we don't want any red and we don't want any clubs, but there are some reds. There are no reds that are clubs. So no reds, no clubs. All right, now down here, this would be experimental probability. A driver collected data on how long it takes to drive to work. So there are 4 trips that take 20 minutes, 8 trips that take 25, and 2 that take 30. So how many total trips are there? I feel like this table, I would like the number of trips to be on top. 14 total trips. So when you're asked this is your description. The time in minutes is your description. It's not a number you're using. So when it says the trip lasts 25 minutes, that would be 8 of the times out of what? 14. And you would reduce that to 4/7. So more than half the trips took 25 minutes. Okay. Now, also pay attention. It says the trip lasts more than 20 minutes. So can I count the 20 minutes? Nope. I'd be counting the 8 and the 2, and that'd be 10 out of 14, which is 5/7. All right. Flip it over on the back. This is going to be more experimental probability because we had 100 people selected out of 2,000. So that's important. So if you add this up, this should be 100 students. The plan was community college, 4-year college, take a year off, go to trade school, don't plan to go to college. So this is what we had from respondents at this school. And there were 100 kids questions. So this should add up to 100. Now we are trying to project it for 2,000 students. So the first thing you're asking, they're actually just asking, suppose one student is chosen at random. What's the probability they take a year off before college? Okay, so we're actually just looking at probability. So how many kids take a year off before college? It said 12, and that should be out of what? 100. So reduce it, should be 3/25?
Yeah.
Okay. Now, I thought I was going to ask you guys to project. So if I said, out of the 2,000 students, how many would you expect to take a year off of college? We would take 3/25 times 2,000. We actually are just finding the probability, so we're not asking for what you would expect out of 2,000 students. So, but if I was asking you what to expect, then you would take that times 2,000. All right, just pay attention if it says or the word not. That's important. And then here is your spinner. The spinner is spun once. We want to know the probability this place is an odd number or a black space. So this 6 is considered the black space, and then the 8, the 2, and the 4 are the gray. On this, it doesn't look the same. So again, the 6 is the darker spot, and the 2, 4, and 8 are in gray. And you're going to ask these probability or answer those probability questions.